In this Houdini tutorial, I'll cover scattering from start to finish, first creating tile variations to instance, then creating the points to scatter onto. I will show common ways to adjust index and pscale, and, more importantly, share techniques for getting the exact orientations you want. I will then translate this into LOPs and cover some of the quirks of the Solaris Instancer, as well as material variation across your scatter. And lastly, set up a quick render for the thumbnail. You can get this HIP file from my Patreon if you're part of my subscriber tier. I'm currently running a 7-day free trial, so if you find this video useful, you can subscribe and then cancel if you want. To create my tiles, to start with, I'll put down a box and scale it down in Y to 0.1 to get a tile shape. I'll then put down a labs edge damage node and view that. By default, it's using VDB, but I'll set the method to Boolean, and this will just create damage along sharp edges. I'll increase the amount to 4 to get slightly more damage. I'll copy paste this edge damage node twice more. And I'll set the seed to 1 for the second edge damage, and the seed to 2 for the third edge damage. This will give me 3 unique tiles. And I'll lay these out a bit nicer. Then I'll put down a merge and merge these 3 edge damage nodes together. If you're interested in more advanced erosion, I strongly recommend this Blender tutorial by CG Matter, which, although it's done in Blender, it's done with geometry nodes, so it's pretty easy to translate into Houdini. Instead of naming each tile individually, I can put down a connectivity node and set the connectivity type to primitive. This will create a class attribute for each tile. I can use this to visualize the 3 tiles a little better by putting down an attribute promote and promoting the class attribute from a primitive to a point. And then using an attribute wrangle, which is running over points, to shift each tile in the X by their class attribute. I'll also space them out a little more by just scaling it up by 10%. And now I can see each of my 3 tiles. Since these nodes here are just for visualization, I'll color them a dark gray, and I'll also rename this attribute wrangle to viz tiles. Also, it's more conventional when scattering to use an attribute named index instead of class. So I'll change the output of the connectivity to index and then change the class attribute name in these 2 nodes too. I'll also rename this connectivity node to index per tile. For the purpose of this video, I'll create more variation between my 3 tiles. I'll leave my first tile as it is. For my second tile, I'll set the noise to be centered, and this will create erosion everywhere, not just on the edges. For my third tile, before the edge damage, I'll add a clip. And I'll set the direction of this clip to 1, 0, 1. And this will clip it diagonally. And then I'll set the origin in X to -0.8 just to clip this bottom corner here. And I can visualize these 3 tiles again. And it's pretty obvious which tile is which now. Of course, using this setup, I can create as many tiles as I like and simply plug them in, and they'll be automatically indexed by the connectivity node. But for this video, I'll just stick with 3 tiles. I can use my index attribute to create a unique name for each tile. So I'll put down another attribute wrangle, this time running over primitives, and create a new attribute s@name, so a string, and set it equal to tile plus, and then I'll use the itoa function to convert the index attribute from an integer to a string. This will create a new name attribute, tile 0, tile 1, tile 2, according to the index attribute. I'll rename this attribute wrangle to name per tile. Lastly, I'll put down a null and simply say out tiles, and I'll color that black. Next, I'll create the points to scatter my tiles onto. So I'm going to place down a grid and view that. And I want this grid always to have quads because I want a tiling pattern where my tiles are square. But currently, for example, if I change the size X, these polygons are going to become stretched. because of the ratio of the sizes. So I can fix that by setting the columns equal to the number of rows. Whoops. If I copy parameter and paste relative references. But then I need to multiply the number of rows with the ratio of the sizes. So multiplied by size X divided by size Y. And now if I, for example, change the size X, it will maintain quads. Note that they won't always be perfect quads. For example, I'll set size X to 10 again, size Y to 4. So size X divided by size Y will be 2.5. And then if I set the rows to a number like 3, then 3 times by 2.5 gives 7.5. But I'm getting 8 here because columns has to be an integer, so it's going to get rounded. And you can see these aren't perfect quads, but we'll always get the closest approximate to quads. So I'll just set these all back to their default at 10 for now. And then I'll put down an add. And I'll rename this to only points. And say delete geometry, but keep the points. And now I'll just have my points. And I'll rename this grid to quad grid. And you can play with the size however you like, and you'll get more or less quad tiling, if that's what you're going for. So I'll put down a null and say out scatter points and color that black. And then I'll come down here and put down a copy to points. Just to be maybe a bit neater, at least in my head, I'm going to use object merges, and this one will be the tiles. And then I'll copy paste that, and this one will be the scatter points. And the tiles go into input geohandle 0 and scatter points into the second input. Okay, and I'll get this. Probably in my copy to points, I should check pack and instance. That will be a bit more lightweight. But currently the issue is that if I go into wireframe mode, you can see all 3 of my tiles are getting scattered onto each point, which is not what I want. I want 1 tile per point. To fix this, I need to create an index attribute on my scatter points. Houdini calls it a piece attribute here, and I need to use this piece attribute to tell the copy to points node which tile, as per the index attribute we've created, should be scattered to which point. So before out scatter points, I'm going to put down an attribute wrangle and view that. And to create my index attribute, I'm going to use the vex function rand, which creates a random number between 0 and 1 from a seed. So I'll create a new variable float rand and set that equal to rand using the vex function, and my seed will be the point number. So since I'm running over points, and each point has a unique point number, each point will get a unique rand value, which is what I want. Then I can use rand to create an index attribute. And I'll set that equal to, and what I need to do is fit rand, which currently is returning a number between 0 and 1. And I need to fit that number between 0 and 2. And that's because I have 3 tiles. So this will return an index attribute between 0 and 2. I need this to be an integer, so I can wrap this in int. And now index will either be 0 or 1. And that's because even though before, without wrapping it in int, I was getting a number between 0 and 1.99. Int will act like a floor, and it'll round down. Even numbers like 1.99 will get rounded down to 1 instead of rounded up to 2, as you might expect. So I actually need to fit this between 0 and 3 to get values between 0 and 2. And before index, I'll put I to make index an integer. And now I'll get an index 0, 1, or 2, which is what I want as like for my tiles. If I look at the primitive attributes, I have an index 0, 1, or 2 since I have 3 tiles. Instead of using int, I'm going to use floor, since that's maybe a bit clearer. And I'll view my point attribute here, and that will not change anything. It will do the same thing as int. To make this code a bit more user-friendly and give it some, I guess, quality of life improvements, firstly, I'll make a seed parameter. So I'll say float seed equals channel f, and I'll just label that seed. And then I'll also say int var_num for variant number, or whatever you want to call this variable. And I'll make another channel, channel I, an integer channel, and label that number of variants. And I'll press the plus here. Okay, so since my number of variants is 3, well, first I'll put var_num and I'll replace the 3 here with var_num. And now my index is just always 0 since number of variants is currently 0. So I'll put that back up to 3 and I'll get back my index between 0 and 2, 0, 1, or 2. And then to incorporate my seed, I'm going to add that to the point number within the rand function. So nothing will change since seed is 0 right now. But if I change this, you'll see my index attribute changes. And maybe to visualize this a bit better, I'll put down a color. And I'm going to color that gray and say viz index. And then I'm going to set this to random from attribute. And I'll color the index. And now there'll be a random color for each index. So yeah, as I change the seed, I'm not sure if you can see this, but all the colors are changing. Also, out of habit, I'm going to go into the parameter interface. And I like setting the range of the seed between 0 and 1,000 and applying that. And then I can flick between 0 and 1,000 very easily. Also, a side note, I always add my seed within my rand function, because if you multiply your seed and then you accidentally leave the seed on 0, you'll see that your index attribute is always going to return the same number, since it's always going to be rand of 0, whereas you need rand of, and this number within rand needs to keep changing. That's why I always add my seed to prevent accidentally leaving the seed on 0. I'll just rename this attribute wrangle, create index, and go back to my copy to points. And I'll go out of wireframe. And now I can use my index attribute as my piece attribute, and I'll say index. And you can see now each tile is copied to its corresponding point according to the index attribute. And also I wanted to mention, if you don't want to write code, you can also use an attribute adjust integer. And you can use this to create an index attribute. So I'll rename the attribute name to index. And let me view that. And set the operation type to set always, since we haven't created an index attribute yet. And the pattern type to random. Then you get this remap ramp here, and you want to keep your min value at 0. And your max value should be, in this case, is 2, since I have 3 variants. So I'll set my max value to 2, and you can see I get an index 0, 1, or 2, the same as I get here. The reason why I prefer using code in this case is because I personally find this more readable than this UI when I'm doing something simple like this. But maybe if you wanted to bias the index towards a certain value, it might be nice having a remap ramp here instead of also writing that in code. To create the pscale attribute, I'll use an attribute noise float. And by default, this already creates a pscale attribute. Let's view the copy to points node. And you can see if I bypass this and don't, I'm adjusting the pscale here, so the scale of each tile. I'm going to set the operation to set, since I don't actually have a pscale attribute. And I'm going to use range values min max. And my minimum value I'll set to 0.9 and my maximum value to 1. And you'll notice that for creating pscale, I am using the attribute noise float node, since that gives us much easier access to different noise types and using noise types than writing it in Vex would. My current setup has an issue. where if I change the resolution of the grid, for example, the size or the rows, I'll just set the rows to 14, then you can see that the gaps between my tiles do not stay consistent. There are a few ways to fix this. For example, I could manually adjust my pscale, but this is quite a manual process, so I'll undo that. Another way is to scale down the box that I use as the base for my tiles. For example, I could change the size here, but you can see this is very slow for my computer as it has to recook the edge damage nodes every time I adjust the size. So if I try to do this live, it's pretty laggy. I'll undo this. Also, I like that my tiles are 1x1 size in the XZ plane, as this is a nice standard size that I could cache out and then work with later. So I think that the best option would be to scale down my tiles just before scattering them. I can put down a transform from centroid node here, and then just scale them down here. And this is much more responsive. But instead of doing this manually, I'm going to do this procedurally by creating a unit tile size for my grid. I'll put down a blast node here, and I'll view this and set it to delete non-selected. My group type will be primitives, and you can select any primitive since they are all quads, but I'll just use prim0 since my grid should always have at least one primitive. Now I'll use a poly extrude, and I'll set the distance to 0.5, and I'll output the back. Alternatively, you could use a labs thicken node and set it to both directions and change the depth, and this will achieve the same thing. Next, I'll use a match size node to center this on the origin. And I'll rename this node to origin, and then put down a null, and I'll say unit tile. But I won't capitalize this as it's just for internal referencing. Now I can go back to where I copied the points, and instead of using this transform from centroid to scale them down, I can use another object merge and bring in my unit tile. And I'll rename this unit tile. And then I can use a match size. And I can scale my tiles to match the size of my unit tile. I don't need to translate, so I'll uncheck translate and check scale to fit. And then use that as my tile instances. And now if I come back up here and change the resolution of my quad grid, the base size of my instancing tiles will always be based on this unit tile size, and it's very responsive. I can come back to my pscale now and set the min value at 1, and you'll see I'll get almost no gaps. There'll be slight gaps just because of the erosion, but now I can have better control over my pscale. I think I'll set the minimum value to something like 0.97, just to have a more subtle effect. At this point, we now have the index to define which tile should be copied to which point. We also have a unit tile based on our grid to more conveniently size the tile instances before they are scattered. And we also have a pscale for some randomization in the sizing of the scattered tiles. It's now time to talk about orientation. Now I'll put a normal node after my quad grid, and I'll compute the normals over points. Don't worry about the scattered tiles for now, I'll just view the grid. And I'll open this up and view these normals. To calculate the orient vector from these normals, I'm going to use two functions. The first is the make transform function, and in this case I'll use this first one, which takes in a z-axis and y-axis parameter, and then from that builds a 3x3 transform matrix. And then I'm going to feed this 3x3 transform matrix into a quaternion function, this one in this case, and that would take in our transform matrix here and create a vector 4, which will be our orient vector. I'll put down an attribute wrangle. And firstly, I'll create my transform matrix. Matrix 3, I'll say rot for rotation equals make transform. And then I need my z-axis vector. So in this case, this will be our normals. And conventionally in Houdini, in your local axis space, your normals will be the z-axis, your up vector will be the y-axis, and your out vector will be the x-axis, which generally is equivalent to NTB or normals tangents by tangents, just depending on terminology. But Houdini terminology is usually normal up and out. So I'll say v at n, and then I need an up vector. And for my up vector, I'll just set it as the z-axis. So I'll say vector up equals 0, 0, 1. And then after I've created this transform matrix, I'll create my orient vector for p at orient and set that equal to quaternion of our transform matrix. And we'll get the orient attribute. To view that, I'm going to put down an attribute visualize or visualize attribute and say vis orient and color that gray since it's a visualizer and that's my convention. And type is marker, style is axis, and then the attribute is orient. And I'll view that. So now you can see the orient axis on each of our points. Since we just have a flat grid, all our normals are 0, 1, 0, so just pointing directly up. And we defined all our up vectors to be pointing directly in the z-axis. I'll rename this attribute wrangle to create orient. And now let's look at what our copy to points is doing. And we can see that all our tiles are skew. And maybe the clue was in the name, but we probably want our up vectors to be pointing up. But currently, you can see our normals are pointing in what we want to be our up direction. So one way we can fix this is just switch around the normal and up vector in the make transform, which is telling the make transform that our y-axis is our normals and our z-axis is our up, which is the wrong way around in this case, but it works. So now if I view my copy to points, all my tiles are flat as they should be. And I also wanted to mention that I am deliberately creating my orient attribute before I'm converting this only to points, because although in this case, I just have a simple flat grid and this case won't make a difference. For more complex geometry, Houdini won't know how to create normals and tangents based off just a point cloud, and it will need your edges or polygons from your grid. And then you can use nodes such as polyframe, where you can calculate your tangents and bitangents using various different styles. Or you could write your own custom code to calculate them yourself. Now I'm going to deform my grid to get a slightly more interesting effect on my scatter. So I'll view my scatter again, and I'm going to put down a mountain node and plug that in here. And the mountain node by default in the post-process section will recompute my normals. So I don't need to recompute them again. You can see my normals are going skew. If I exaggerate this, my normals are correctly skewing according to the mountain. I'll undo that. And now I'll visualize my orient attribute again. And it's correctly being created. Note that if I try do this before my mountain node and visualize the orient, it's not going to work properly because the mountain node will only recompute my normals and not my orient attribute. So I'll put these back around again. And I'll neaten this up a little bit and rename mountain to deformation. As a side note, some other nodes, for example, the transform node, will actually recompute orient for you if you tell it to. Before using orient, I want to show one last vex function, which is qrotate. And this will rotate a vector by a quaternion and return a vector. And an example of how this could be useful, I'll put down an attribute wrangle and copy paste some code. You can use this to decompose the orient matrix back into its subcomponents, for example, the n and up vectors. So I could put down an attribute delete and delete non-selected except for orient. So now I only have the orient attribute on this. And let's view this. And currently I'm viewing the normals and you can see it's just Houdini default normals. But after this attribute wrangle, I've now recalculated my normals and you can see they are the same normals that I have for my orient over here. And I will actually keep this node here because I actually want to have the correct up and n vectors according to my orient. So I'll just rename this attribute delete to del not orient and color that a light red. And then this attribute wrangle, I only need the normal and up, so I'll delete these two. And I'll delete this. I had a second method, but I won't show that here. And I'll rename this to decompose orient. And I'll move everything up to create some more space. Now I've discussed every function that I want to. I'm going to start moving a little faster. And I'm going to start by pasting in a node I have here to do a common thing, which is to rotate your normals about your up axis. So I can see what this is doing by visualizing my orient. And when I change this, it will rotate all my normal vectors randomly about my up axis. You'll see that the shading gets messed up a bit because Houdini uses your normals for shading. So I'll turn off the lighting. I'll just give a quick overview of what this is doing. Like before, I'm creating a random number between 0 and 1. I'm then fitting this random number between the negative of my angle and the positive of my angle. So if I set this to 50, this will result in a random number between minus 50 and plus 50. I'm then converting this angle to radians and using the quaternion function that we just saw. Except in this case, I'm using it with an angle and an axis to create a rotation vector for. And then I am updating my orient by multiplying this rotation vector with orient and decomposing orient to get my normals and up vectors again. This normalization is actually redundant. So this piece of code is obviously very useful when scattering. In this example of scattering tiles, another useful way to manipulate orient would be stepwise rotation. So I'll copy paste this node in here and set this to 0. And actually, before I discuss this node, I'll just view the copy to points again. So it looks like I overdid my random rotation, obviously, because I did 50 degrees. I'll set it to something more like 2 or 3 degrees, since I do want these tiles to look like they're tiling. And I'll also turn my lighting back on. Now I'll plug in this stepwise rotation and move down my visualize orient. So this node is very similar to the last. I create my random number between 0 and 1. And then my angle parameter is now just a step angle. So typical values might be like 45 degrees or 90 degrees. And I'm actually going to move my only points node up here because changing the normals is messing with the shading, which is a little distracting. Okay, so you can see as I change this stepwise, it's clearer when I do 90 degrees, for example. My normals have been randomly rotated about the up vector by 90 degrees, which is pretty clear here. Maybe if I turn off my 2-degree random rotation, you can see it's very geometric as a 90-degree step would look like. And what this is doing is, so I define my step angle. I also put this if step is not 0, because if I put step to 0 here, I'm going to get a division by 0, which Houdini won't actually error out on, but it's probably not a good thing to have. So I just say if step is not 0, I'll fit my random number between 0 and 360, which will result in a random number between 0 and 360. Then I'll divide that number by the step, floor that, and multiply it back by the step. So if I set this back to 90, for example, after getting my random angle between 0 and 360, here I'll divide it by 90. So this will return a number between 0 and 4. 0 divided by 90 is 0, and 360 divided by 90 is 4. I'll then floor that, which will return a number 0, 1, 2, or 3, an integer, since all numbers from 0 to 1 will get floored down to 0, from 1 to 2 will get floored down to 1, etc. And then I'll multiply it back by the step. So this will return angles of exactly 0 times 90, which is 0, 1 times 90, 90, 2 times 90, 180, and 3 times 90, 270. And that's the stepwise rotation that I want. And then I'll just convert that to radians, get my rotation vector, and update my vectors. And again, these normalize are redundant. So this is quite useful in the case of my tiles, since I already get a much more random pattern. We can see without it, for example, all my chipped top right corners are very obviously all in the top right, and it's pretty obvious I have a repeating pattern here. And so for that tile in particular, it's very obvious that it's just the same tile over and over again. But as soon as I introduce this variation, it does look a little more variant. I have created 3 tiles which are very distinct, which is definitely not good for scattering, but I've just done that for the purpose of this video. And then I'll bring back my random continuous rotation, which doesn't do too much, but just adds a subtle little bit of skewness to each tile. Maybe I'll increase this to 4. I'll also reduce the amount of deformation I have here to maybe 0.15, maybe even less, 0.1. And that's a bit nicer. Now I can repeat these 2 things exactly, just except for rotating n about up. I can rotate up about n. So I'll move up these nodes again. And maybe I'll add a little space between when I convert to points. And I'll also just move these over here because my layout is getting a bit messy. Okay. I can also delete this attribute adjust index, and now I have a little more space. To randomly rotate up, I can just copy paste this node and plug that in here. And I'll color this green since that's the conventional color for the up vector, and say randomly rotate up 1. And let's see what's happening. I'll turn off these rotations and also my deformation for easier visualization. So firstly, I'll change this comment to randomly rotate up about the n axis. And then the only change I need to make is to change my axis from via up to via n. And now if I change this, you'll see my up vector will rotate about my n axis. So my n axis is here and my up vector is rotating around it. And let's see the effect on my scattered tiles. Definitely too extreme, so I'm going to reduce this quite a lot. Probably to something like 2. And then I can also use stepwise rotation on my up vector. Since in the case of tiles, the viewer only really sees one side of them, so randomly flipping them over is almost like doubling your number of variants. Let me uncomment this and color it green and say randomly rotate up stepwise. I'll view my orient again and hide this one. And I'll change this comment to rotate up about the n axis stepwise. And then I'll simply change the rotation axis from via up to via n. Now my up vector is going to get randomly rotated stepwise around n, but I don't want it to be 90 because that's obviously going to look quite odd. I want it to be 180 to randomly flip them up or down. Great, I've now created quite a lot of randomization in my orientation. So I'll unbypass all of these. And this is the result. Even with just 3 very distinct tile variants, you can see the scatter is quite effective in creating a random look as if each tile is unique. To get a better view, I'll increase the resolution on my grid and I'll up its size to use something much larger. I'll also add the 3-point lighting with ambient occlusion and turn off my background grid. And we get something that looks pretty nice and random considering we only have 3 pretty distinct looking tile variants. Before heading into Solaris, I also want to go over a quick example. Here I've put down a subcreate to create a shapes component inside of which I have a cube, cylinder, and sphere primitive. And inside this subcreate, you can see I have a sphere here. Above the sphere, I put a font node and specified the index attribute of the sphere. So you can see I've named it sphere and created an index of 0 on it. And I've done the same for the tube, where I have a font with index 1 and the tube index is 1 with name cylinder. And again for the box, index 2, index 2. Now in Solaris with these 3 shapes, I've put down an instancer inside of which I just have a line with 3 points. And I've created an index just equal to the point number. And I've manually created a name for each index. So if I visualize this, you can see my 3 points have an index of 0 with the name sphere, index 1 with name cylinder, index 2 with name cube. And if I come back into Solaris and view this instancer, By default, the prototype index is random. So first I'll set it to index attribute. And the first thing you'll notice that even though this point has an index 0, this 1, and this 2, it does not match up to the corresponding index attribute on my shapes. I can open the side panel here, click on a shape, and find the index primvar, and see, for example, my cube has an index of 2, as I specified in here. And you can see here. Yet this point in my instancer has an index of 0. So why is my cube being instanced here? Well, the answer is that the instancer in Solaris is not using your index primvar. It's actually creating an index attribute according to the order of your primitives. So since my cube alphabetically comes first, this actually gets an index of 0. My cylinder will get an index of 1, and my sphere will get an index of 2, which is why they are instanced in this way. That's why in Solaris, I prefer instancing by the name attribute, because then it doesn't matter what order my primitives are in, and it will act a lot more like the SOP copy to points, where a point with a given name attribute will receive the instance with the same name attribute. In fact, if I set my shape instancer back to index attribute and pin the Solaris viewport, inside my SOP create, I can remove the index attribute entirely, bypassing it, and it will make no difference because, as I said, the Solaris instancer is not using this index attribute. So I could do something like rename each of my shapes if I unbypass these 3 renames here. And then it would change to be in the correct order because I've specifically named them index 0 underscore, index 1 underscore, index 2 underscore, which causes them to be ordered in the correct order alphabetically. I had to prefix each name with IDX because in Solaris, you can't begin a name with a number. So if I tried to rename this to 0 underscore, for example, and go up, you'll see that my sphere just gets renamed to underscore underscore because you can't start the name with a number. So I'll return that to prefix IDX. But in my opinion, it's better just to instance using the name attribute itself, rather than trying to name each of your instances so that they are ordered correctly when Solaris sorts them. So I will return my instancer to use the name attribute that I have created on my points. If I unpin this Solaris viewport, so now each point is pointing to the name of the primitive in the shapes component. Before heading into Solaris, I will move this match size and unit tile here up to before my out tiles null, since I'll be referencing this null in Solaris. And I'll also go back to my scene lights, turn off ambient occlusion, and I'll turn off my normals. And I guess I'll also set my work lights back to headlight. Since I want to scatter using name in Solaris, I'll copy paste this name per tile attribute wrangle from earlier and set it to run over points to create a name attribute for my points. I'll rename this to create name. This is just for demonstration since this name attribute on my points is random anyway, so I could have just used the random built into the Solaris instancer. Lastly, I'll put down an attribute noise to create a random seed on my points. So I'll set the attribute names to float seed, the operation to set, then I'll visualize this seed using a color node. I'll rename it to viz seed and color it gray, then set it to ramp from attribute, and I'll use seed and view that. And I'll set it to infrared. I'll rename my attribute noise to create random seed. And I'll play around with my element size. I think I'll do something like 4. And then I'll just straighten out my nodes. Now I'll head into Solaris, into the LOPnet I created earlier for my example. I'll put down a SOP import and I'll get my tiles, out tiles, and view that. And I should have my 3 tiles, tile 0, tile 1, tile 2. And I'll rename this to tiles. Next, I'll put down an instancer. And this needs to go into the second input, since these are the prototype primitives. Inside my instancer, I'll put down an object merge. And I'll grab my scatter points. And let's see. I'll put down an output node after this and rename this to out and color it black. Even though this is redundant since I only have 1 node in here, but I think it's a good practice. So I'll go up and let's have a look at the instancing. So currently the instancer is set to random. And if I look at what's going on here and go into wireframe mode, I can see that all three of my tiles are getting instanced to all the points, so they're all overlapping. And this is because the prototype primitives is pointing to the tiles component rather than the 3 tiles inside. So I'll change this to /tiles/ and use a wildcard. And now that problem is solved. I'll come out of wireframe and reframe the viewport. And what I want to do is, instead of using random, to use my name attribute. Now I'll apply a material to my tiles. So I'll put down a material library, and inside I'll put down a USD material X builder. I'll rename this to tiles material X material and head inside. I don't need this inputs node and I won't use displacement. Next, I'll put down a constant and I'll set the signature to color, and the value I'll set as this browny orange, and I'll plug that into my base color. I'll head back into LOPs, select assign to geometry and just use all. And if I view that, I can see that this color has been applied to my tiles, but when I instance them, the color disappears. To fix this, in my instancer, I can use the parent component /tiles as my prototype primitive. Initially, I'll get a warning because it can't find any of the tile names. If I then secondarily say all mesh primitives, then I'll get my tile instances back. And now if I put my material in my tiles component, like so, then the material will get applied in the instancer. I'm actually not sure if this is an intentional design, but it does work. And if your instances aren't a type mesh, you can still use /tiles/all, and it will still work just fine. The important thing is to just specify your parent primitive, which contains both the geometry and the material, and then secondarily point to the geometry that you want to instance. And this seems to work to keep the materials. There are some other methods to keep the materials during instancing, but this is my favorite one. I'll rename this instancer to tiles instancer and straighten out these 3 nodes. Next, I want to use my seed attribute to drive variation in my material. So I'll put down an MTLX geometry property value, and I'll read the seed attribute, which is of type float, and I'll rename this to primvar seed. Then I'll plug this into an MTLX random float. And I already know that my seed has a minimum of 0 and maximum of 1, since that's how I created it. I'll move these back a bit and put down an MTLX color correct, where my random float is going to be the hue, and this color that I've created is going into the color, and I'll put the result into the base color and rearrange these nodes a bit. Although this appears to have affected all my tiles by the same amount, even though I have a different seed value on each point, when I go into Karma XPU, you can see that there is now a different hue applied to each tile. This hue adjustment is obviously far too much, so I'll raise my minimum to 0.99 and my maximum to 1.03. And now I just have slight color variation across my tiles. I also want to mention that the seed attribute is not on my tiles, it's on my points. So it's quite interesting that I'm able to use the seed attribute in this material when I'm creating the material before I'm even instancing my tiles. It might be a better practice to use an edit material node, load in your material, and then instead apply the seed after instancing. But since this seems to work, I'll just do it this way. Obviously, if I just look at the tiles themselves, there is no material variation by the seed because they don't have a seed attribute. It's only after they are instanced and they receive the seed attribute from the point instances. I have gone back and applied some UVs to my tiles, but I won't cover that here as this video is getting quite long. But again, this file is on my Patreon if you want to subscribe. I've also applied this rock texture from Polyhaven, which you can get for free, and this is the result. Lastly, to make the thumbnail for this video, I did do a second scatter, and I literally just used the same scatter I have here and moved it up a bit, and then increased the pscale since I also scaled the scatter out. Then in Solaris, I instanced that second scatter here, put down a Karma physical sky, very simple, a Karma fog box, a camera, which I'll look through here, and I'll turn on Karma XPU, and then some basic render settings with the denoiser. And that was my thumbnail for this video. Thank you for watching, and I hope you found this tutorial useful and consider checking out my Patreon.